Welcome to Activity 3.3, and if you're in your book, so I'm looking at the book right now, you should be on page 30. So investigating how a pendulum works. So our learning target is we're going to develop and use a model to explain the gravitational and kinetic energy conversions in the pendulum. So if you remember back on Activity 3.2, we looked at a box or a brick that was falling and how the energy conversion goes back and forth between GE and KE. So now we're going to look at a different example. We're going to look at a pendulum. So the expectation for you is you will be able to write a CER explaining the energy involved in a pendulum. So here are the directions that are on the top of page 30. In the following diagram, the circles represent 5 different positions of the pendulum as it's swinging. Position 1, which you can see right here where the cursor is the point where the pendulum is released. Position 3 is the lowest point. Position 5 is the highest point the pendulum reaches on the other side. So it's the highest. Position 2 is somewhere between 1 and 3, while position 4 is somewhere between 3 and 5. So for each of these positions, you guys are going to draw a pie chart like we did in Activity 3.2. And that pie chart should describe the relative amounts of GE and KE that the pendulum has at that position. Identify the point where there is the most and the least amount of kinetic energy and gravitational energy. So, and number 4, the final direction says, use the claim, evidence, and reasoning framework to explain what happens to the pendulum's energy as it swings from position 1 to 5. So we're going to do one together, and then I would expect you to finish these up on your own. So let me get a pen here. So we look here, and again, if we go back to number 1, and I'm reading it out of the book, it says position 1 is the point where the pendulum is released. So this is where you're going to have to interpret this. Was it released? Was it just released? Or was it still in hand and where it's going to be released? Now, if you read it, it says where the pendulum is released. So how about we say there is a tiny sliver of GE and KE. Sorry, KE. So what I'm going to do is I'm going to create a key. And I'm going to make KE green. I'm going to make GE blue. So anytime you see blue, it's going to be KE. So if I look at this, if this is position where the hand is released, if it was just released, there should be a little bit of KE because it's just getting started. So I might draw just a line down here and make it a little bit wider because it's just starting. Then what I would have to do is I'd have to go in here and the rest of it should all be blue. So go ahead and create yours. Now if you have a pencil, you can make it dashed, you can make it dotted. Somehow, though, you want to divide this up. And I'm not going to be able to necessarily fill it in completely, but you'll get the point that everything else should be blue. Okay. Pretty good coloring, hey? So that's your energy conversion diagram. There's just a little bit of KE because the ball was just released. It's starting to move, and then it should be mostly GE. So now, what you have to do, if you look on page 31 at the top for position 1, it says claim. What types of energy are involved? This is where you'd write a claim. And for this, let's do this one together. What would the claim be? What types of energy are involved? Well, you would say that most of the energy is GE, but since the ball was just released, there is a small amount of KE. Evidence, how do you know? Well, this is where you can say that the hand was just released, or the pendulum was just released, so there's very little speed, thus it will not have a lot of KE, and because it's almost at its highest height, it has mostly GE. So your reasoning is what is happening with the energy. So your reasoning is, so because the pendulum is starting to fall, you've got mostly GE and it's going to be converted to KE. So your claim, evidence, and reasoning. It doesn't have to be very lengthy because you can see you've got to do one for position 1, 2, 3, 4, and 5. So I call these mini CERs. So you should have at least a sentence for your claim, a sentence for your evidence, and a sentence for your reasoning. So what you need to do is you need to finish up positions 2, position 3, positions 4, position 5. So when I go to the next slide here, you would see you'd have to create a circle. Oop, let me get rid of my pen. So here we are at position 2. So now it's blank. You would have to go back and you would have to fill this in for position 2. Then create a circle for position 3, position 4, position 5. And for each one of those, write a claim, evidence, and reasoning. What types of energy are involved? How do you know? What is happening with the energy? And once you get done with these positions for 1, 2, 3, 4, and 5, then there's a conclusion question. Describe how the pendulum works. When you get done with everything, just show it to your teacher. Make sure you ask your teacher if you have any questions while you're working on this, so that way you'll get the full, you'll have a full understanding of how this is working. That way, if it's on the test, you'll know. But again, make sure you ask the questions versus coming up later and saying, well, I didn't get how to do it. Then we would ask you, well, why didn't you ask? So this is for activity 3.3.